Yeah, so my name is Bhavesh, and I am having a experience of roughly around 7+ years in IT, and then in ML it's more than 6+ years. And overall, I have worked as a data scientist. I have worked as a machine learning engineer. I have worked as a MLOps person as well. So I have a brief idea about the current industry standards and what is used in the MLOps work profile. So that's the reason I am here to share that knowledge with you guys. So that's a brief about me. And this course, let me talk about this specific course. So this course is specific to the ML ops, and we'll cover in depth techniques and things that are used in the ML ops. So there are many things, like right now the industry is adapting, the Gen AI, if you see, the LLMs, and maybe the machine learning models, traditional models are also there. So we see few of the use cases, how these models are, getting deployed in production. So today is an overview or maybe a demo class, which you can say. And here we'll cover a high level idea about MLOps, what MLOps is, what all things are there, what are the challenges, what tools are used. So all that things will be covered. And after that, we'll walk through the syllabus as well, what we are covering so far. And, there are a few things that we can discuss. So yeah, let's get started, and I would like you to invite on the next 1 hour to focus on this particular session, because this can be a game changer in your understanding on MLOps and how you want to steer your learning on MLOps. So I think many of us have joined in the Saturday morning. So first of all, thank you. And I can understand, like, you guys are interested, but with the interested, we need to keep this session interactive as well. So I would like to hear things from you, because we need to have certain basics of ML and basics of Python before MLOps, right? So that's why we will ask you a few questions, and we need your answers on them. So let's get started. The first thing is that I'm covering right now is challenges of the operational ML systems. So what do I mean by the operational ML system, right? So operational ML system is nothing but where we have a model which is placed, and it is getting deployed in some system which is getting consumed. Okay. What do I mean by which is getting consumed? That means it is loading or maybe predicting things which is used by some of the other business downstream process. So there are upstream processes and downstream. So we are getting, like, our we'll get data from somewhere, right? So that's the input for us for a ML model or a system. Let's say now we are talking about ML system, right? So what is a ML system? It will take some data and some inputs from different sources, and then it will finally give you an output, which is a prediction. So this prediction is getting stored or maybe getting used or consumed by some downstream process. That is what the business process usually is. Say example, if I am doing a forecasting project, right? So sales forecasting. So what is the downstream process for me? It's like the supply chain of that company, right? So if I say about sales, right? So sales, who is the marketing team will be there. How do we have to market? How do we have to do the supply chain team will be there? Is there enough supply? Say example, I am saying 100 units will be sold in a month of March. But what if, like, I have only 60 units ready? So my supply chain team has to make sure that another 40 units are there ready to be sold. Otherwise, we'll have to change the things, like we'll have to make prices little higher. So that's more about demand and supply. So that's one just example. So what a system looks like. So similar things we are looking the challenge in the operational ML system. Right now you understood what is operational ML system. Now let's understand what is the challenges. Okay. So the challenges, if you see, of the operational ML system is, like, first of all, more than 87%, or maybe, like, close to 80, 85, 90%, whatever this rough number is. So there are multiple researches and surveys that have been done. from the year 2019 over like 2023, over a 3-4 year period. They have done multiple researches. Okay, and the number that they are quoting is 85 to 95%. Okay, there are multiple differences, but yeah, the number which is fairly considerable is 85, we can say. So 85% of the data science project never make into the production. So what does that statement mean? It's like you are training a model, you are using some experiment data, you're using some hypothesis to train a model or maybe solve the problem, but you are not able to put that model to production. That is the statement. And do you think like it's so big number, like if you say out of 100%, 85% things are going not going in the production, so which is a big thing, right? So that much effort of any data science team is getting into win. So this is not only condition of some startup company or some high level MNC. This is all across the globe. Like it's of every company. So nowadays things are changing. That's where the advent of MLOps comes into picture. Like that's where the MLOps helps us. It helps us to reduce the cycle of model from training to production. So that is what the MLOps is doing. So you might be knowing, some of you might be knowing DevOps, right? So what was the DevOps invented for, and what is it used for? It's used to reduce the like the short route from training to deployment, or maybe like from development to production environment. So that is what similar MLOps is, but it is for ML systems. So if you consider the traditional web application, or maybe any the application, you will have like some processes which is governed by DevOps, and that DevOps will be used for taking the things from, like say, the training environment into the production. So the similar case is for ML, using MLOps, but there are different nuances to it, right? Because in MLOps, or maybe in ML, we are not dealing only with the code. We are dealing with the data, that's our input data. We are dealing with the model which is getting trained. So we will have to keep so we'll see all of this. But yeah, just to give you a high level picture, what is the current market condition, what is the need of MLOps. You see, like every company now who is dealing into ML, they need ML engineers and MLOps engineers, right? So both are needed. So what is the difference between ML engineer, ML ops engineer? So this is a very sideline difference. Right now many organizations are not having different profiles, but some organizations have different profiles. So ML ops person will be responsible for following all the practices, that is the standard practices of DevOps, like CI CD, following all the deployment process. And the ML engineer on the other side, they will write production ready code. So usually from data scientists, we might not expect to write them production ready code, right? What do I mean by production ready code? Which is packaged, which is containerized, which is like ready to deploy. So that all things. So this is a slight overlap between the roles of a MLOps engineer. Some organizations expect MLOps engineer to do that. Some organizations have ML engineers. So that's we won't go much deeper into that. But yeah, just to showcase what are the different profiles. One is a data scientist, ML engineer, MLOps engineer. So there is a know, some amount of overlap, okay, between these profiles. So okay, let's keep that aside, and let's go into the depth of ML deployment. So what happens when you do an ML deployment, and why it is difficult? So because if you see, in only application or web, we have only code part, right? And we have a database part. So database part is again we have some database that is talking to a code. That's usually a two-tier architecture. We deploy the database, we deploy the code. But in our case, we don't have only the database or the data warehouse, but we call something as data pipelines, which is constantly working on getting a newest data on our floor. Okay, so these data pipelines will bring newer data and put it into our floor. That is the data. Okay, and then we have constantly, there is a code update going on. Then we have something called a CI/CD pipeline, which is putting the newest code in our environment. Okay, then we have ML pipelines, which are constantly training a new models, and assessing the older models and putting the models into our flow. So if you see, we are dealing from three directions. So this is a three directions that we are dealing. One is a code direction, one is a data, and another one is a model. So, and all the process, if you see, they are ever changing. So data pipelines are always working, ML pipelines are always working, CI/CD pipelines are always working. So you see, we have three different aspects of looking. So one is a data pipeline, one is a ML pipeline, one is a CI/CD pipeline. Okay, so that's how the differences are between a normal software thing and a MLOps, right? So this is where it comes in, like what is the difference. How many of you are getting so far, like so are you following me or having some difficulty? Just quickly, give me a thumbs up, raise your hand, any reaction.
Yeah, we'll follow you.
Perfect, perfect. Thanks a lot for confirmation. I think that's what I need, because I need to understand if you guys are following, if my speed is fast, or maybe like you guys are having the same level of experience that I am.
Hi Bhavesh, good morning. This is Suryam this side.
Yeah, Surya.
Yeah, the thing is actually what are all prerequisites for this MLOps because we have 15 plus years of experience so far in the IT industry in different domains like testing, DevOps and all. But MLOps is looking like from the scratch like Python and all we need to learn and we need to apply, right? So
Yes,
what is your suggestion, please?
let's wait for some time, and we'll take the questions later, and I'll answer this particular question
Mhm.
towards the mid or end of the session, because I need to cover a few things, and then you will have a fair amount of understanding. Okay, then we'll assess what things you have, what things you don't have. Okay, let me
Fine
go
then.
through the.
Yes.
Yeah, I'll take this up, don't worry about it. So yeah, not disturbing the flow right now, but yeah, we have we were discussing about the deployment difficult and what is the ML system at its core. So we understood what three components we are having, what three pipelines we are dealing, and let's say what is our you know experimental data science. So if you remember, like, or maybe if you know that, like, many of the data scientist or the data science work itself happens in a notebook environment, right? So if you say, like, all the different aspects are being done in a notebook, like you write the Python code, you write whatever, you write data analysis code, everything is done into a notebook. And we feel that this is it. We feel that, okay, I have written my code, now things should be fine, right? I have written the model building code, I have written the model training code, I have written the data analysis code. Now this is the thing, like, I have been sorted. But it's not the reality. In reality, the ML code is only a small function, which we can say a 5 to 10%. But there are many more things to it. Okay. So we have, from starting from the left, going towards the right, we have the configuration, we have a serving infrastructure. If you have trained the model, if you have deployed the model, you need to have some infra, right? So that's configuration and infra. Here you have some processes which we saw, right? There are some data pipelines. So data pipelines will have some data collection things that are working. Then we have data verification. If we are monitoring whether validation, like the data is right data or not, whether the data is useful data or not, you know similar way, you have a ML code. So that code will produce the ML artifacts or things, right? So you have feature extraction and another, like, parallel to the data. So once you have the data, collected data, you will do some feature engineering for ML. So in a ML application, you do some feature engineering and things, right? So that is the core concept. Like, there are many things to it. So we have feature extraction, then ML code, then analysis tools. So analysis will happening, on the data as well as ML code. So both will be analyzed. There are some tools monitoring things that you do. So this is all in the loop. We'll look into a different angle as well to this. But yeah, just wanted to show you this, like, how there is a difference. And then obviously we have machine resource management, the process management tool in any project that's happening. This is a common thing. So hope you got, like, where we are looking right now, data science, if you see, but what the reality is. So we'll look at the, where teams are today. You know, many teams, I would say again, many teams are still on this particular maturity level which we are talking. So I'll introduce a new jargon now. I mean, just to keep you aware. So in MLOps also there are multiple levels. Did you know that? I'm not sure if you people already know, like, in MLOps also there are different levels, like, in MLOps also you can achieve level 1, level 2, and whatever, like every cloud and cloud vendor. So you have some, popular clouds like Azure, like GCP, like AWS. These are all, like, popular clouds. So each and every popular cloud has their own understanding of a MLOps. Okay, they call it MLOps maturity. We'll look at that. We'll look at that in a moment. But let's, this is one of the maturity which we are talking about. This is the lowest level of maturity in any cloud or any project which we are seeing. So this is where, we have most of the teams today. Like, they do all of the left hand side, if you see activity, that's done by a data science team. Okay, so this is the training part. As I told you, right, this is happening in the notebook environment, right? If you see, we are writing code into a notebook environment. How many of you know notebook? What is notebook? Or what is, like, Jupyter Lab or notebook? How many of you know, first of all? I think very few of you know. Okay, let me cover, what is a notebook. So notebook is something where you have already, pre-built things, or maybe like a set environment. Okay, so that kind of environment, maybe we can, show it to you in a few minutes. Let me open my notebook and show it to you as well. But yeah, let's continue here, and then I'll show you, right, what is the notebook, how things happen here. So so usually if you understand, like, local machine, right, you have some local machine, you do the development process on your local machine, you install certain software, right? Say, like, whatever, if you need Python, you'll install Python. If you need something else, like internally Python needs some package, you will install a Python. So you might have, if you have ever worked on Python, you will know something. There is a Python installation manage package manager, that's a pip. you know so pip is again, where you use the installation process. So this is everything, it's done manually, right? So that's the main thing. If you see, the training data is done. Training data will be sampled into a local data, and then local data you will do the manual preparation, you will do the manual monitoring, then you will do some analysis, that is also manual. Once the manual analysis is done, like, the model is working fine, you will see, like, I am happy about the accuracy. So what is accuracy? It's nothing but one metric which we can judge a model whether it's doing good or not. Okay, we're not going into deep, but yeah, just a high level. If you understand, if you don't understand, it's fine. So if, say, we are having accuracy, right? So accuracy score is like 95. It's a very good model. Okay, now I'm happy, like, I have 95% accurate model, but my code is not written in a production ready. So I'll have to rewrite the code. I'll have to rewrite the code from a notebook or my local environment. I'll have to put proper, things into picture. Then with the all documentation, all, we'll put the production model training now. Now I'll use the model training process in the production project. So, in any environment, we have multiple environments. Right? Like in any project, we have multiple environments: the dev, the test, the stage, prod, all that things are there, right? Pre-prod. So depending upon the complexity of the project or the requirements, we can have multiple different environments. What are these environments? If you have done any kind of development, right? So you might have come across like, dev, pre-prod, prod. So these are all like, a typical arrangements, or maybe like some setup that we have. So to replicate the prod, and if something, you have to push something new to prod, you test it before. How many of you are aware about all of this, like, dev, stage, prod, and ever worked into any development? Can someone tell me like what is the dev, test, prod, and if you have ever worked, your experience?
Yeah, I think these are the environments before going to the production.
Correct.
Like we will test, we will develop and test it, and then move to the testing environment UAT,
Yeah, yeah,
and
UAT.
then
Yeah, that's another name like you might have heard. So yeah, these are all like, some names, but at the back end, what is that? We are creating replicas of prod, because if there is any change in the production environment, you will not do it in the production, right? Because if say something goes wrong into a development or stage, that's fine, because that is not your business is not relying on that, right? So your business is relying on prod, because that's so you need a robustness. That's why you have multiple environments. So before going into prod, you will thoroughly test. In the development environment, things can break even like daily, you know new person is there, he is doing something, so things break in development. Then you come to know, okay, we don't need to do in certain way. Now you need to change the thought process. So that's why you have different environments. So depending upon the level of the checks that you want, people keep like dev, stage, and prod. That's simple. Dev, stage, test, pre-prod, whatever, like there can be 4 or 5 environments as well. So depending upon the requirements. So that's all. So how many of you have worked with Python, or maybe like let's ask that question. How many of you have worked with Python? Can you like do a thumbs up, raise your hand, whatever, like any reactions? If you have ever worked with Python, or any programming language for that matter, like let's say if you know any programming language, any one programming language. I see only 2 reactions. Okay, another one. Yeah. So couple of folks have the experience. Okay. No experience, no programming experience. Okay, fine. Okay, that's fine. That's fine. Uh, okay, cool. So I think we have a mixed audience right now. So we have like some people are having experience, and specifically with Python or not with Python. So the reason I'm asking, right? Because many of the industry projects right now are dealt with in the ML. They are getting used to Python, right? I mean, other companies are there. They are using some different languages as well. So even for that matter, the deployment happened in C++ for the low latency things, on the edge deployments, or maybe like Java or something else is also used. But majority of the applications are still uh, done in the Python, if I'm not wrong. Okay, so that's the reason I was asking. And Python is very simple. The level of Python we'll use in the operations is comparatively not very heavy, but yeah, you will have to brush up your Python knowledge if you have done it in the past, or maybe if you have done any programming language, it should be fairly simple. But yeah, you will have to put some effort. Okay, that's true. Without any effort, you won't be able to get the things. So yeah, coming back to the thing, now our model is trained. Okay, if you see, we were doing some analysis, data preparation, model training, and now we have a production model training. Like we have a final training data, we have written the code in the production ready. Okay, now we have our trained model, right? What do I do? I have my trained model ready. What is my next step? Does anyone know, like if anyone has seen any data science project, if you have a model ready, what do you do after a model is ready?
You need to deploy.
Absolutely right. Yeah.
We'll
Let
deploy first on the QAT environment, then pre-prod, then we'll go for prod if everything success.
absolutely. Yeah. Thanks for confirmation. That's the same thing we do, right? We have trained model. That's a what is a trained model? It is nothing but you will have an artifact, right? What is an artifact? It is a package of a model, right? You will serialize the model. How many of you know what is a serialization? If you don't know, don't worry. It's a very basic process. Like if you have any files that you share over internet, right? Be it any manner. So to travel the things, we need to package it or serialize it so that it doesn't get losses or something. Okay. So yeah, while traveling on the internet, we need to make sure. So that's why we need to train a model, serialize it, package it, so that if you are transferring it into any other environment, right, it doesn't get any problems. So that's why we do that. And once you have that, you will prepare the serving environment. The serving environment, what people mention deployment. So serving environment, that means the infrastructure need to be ready. Any code or something that you need to really some maybe you need to install some packages on the new environment, that needs to be written down. So this is again you can do this process manually, and all that things can be done in a automated fashion as well. So we are looking at a manual process right now. So this is a deployment and pre-prod deployment we do. And if there is any unsupported dependency, unavailable data, then you rewrite the things into a things and retrain the model. Okay, say like you get a something new data which you have never seen, and your model is not able to predict on that. So you will note that alert, and you will put the things into training data science team. Okay, we'll see here. How many of you understood this process? Like we are finally reaching the model deployment. So this is the entire manual process. So so far you have understood, right? I mean, or any questions so far on this one. So on this particular topic, if you have any questions so far, I'll wait for 30 seconds.
Uh, we are going to moving deployment, right? So we before going to moving deployment, we are already running the model. So how sure we can this is the model is best and what process we need to take to deploy before the deployments?
Yeah, then. So we are going to cover that particular thing into a later maybe session or something. But right now, since not many people are familiar with the model training process and what is the best model choose, so we are not going into that much of detail. If you see, this is a high level building blocks which we have put. Like this is not covering any detailed workflow. So this will
Okay.
certainly see into the later sessions, but for now, you don't need to worry about that. Like for now, we have not
Oh,
introduced any multiple models. Yeah.
So,
thank you.
Bhavesh, so from this picture only, so where we are working like in this picture, so where we are sitting as a MLOps engineer.
Okay. Yeah, that's a very good question. That's a very good question. So as a MLOps engineer, what's your task? Okay. So your task is majorly in the right of the things, right? But this is a manual process. That's what the problem is. As a MLOps engineer, your goal will to automate as much as process, right? So why we have to automate? Because there it will reduce the number of errors. Now we look at the further process. What is the maturity level, what organizations are currently, and then talk about more about the maturity. So it will come. But for now, if you talk in this particular window, right, we are involved in the right side, preparing the serving environment, model deployment, getting the trained model to the production. That is one of our job. Okay. And if you have to write any production code, if the data scientist has not written, you have to correct them. You have to tell them, this is not a correct level of code. You need to put it in certain way. So that is all our, day-to-day job. If you see, like that might give you some clarity, but once we go further, right, we will come to know, like this is not only limited to this, but this is just a start. We have multiple things to do. Okay, that's a good question. We can continue that question, and I'll tell you more about it. So but let's talk about what are the teams doing today. So as I told you, right, there is a high degree of manual work. Okay. And that work is getting repeated. So there are no reusable, reproducible components. There is a poor handoff between the data scientist and the IT team. That's the ops team. You know, so models don't make into production, that we discussed, and we know why. You know, because they are written in notebook, they are written in local development environment. When you do the development in local, you might use some stale data, right? The data is very very old. You know, you need to talk about new data. So you don't, like, you have done the training in the old data, but when you put the model into production, it doesn't give you good accuracy. That's one of the problem. So models break because they fail to adapt the changes, as I told you, right? If you are if you're doing all the training and everything in the local environment, and you're not testing anything in the pre-prod stage environment, then if you directly, put the things into prod, it might break, right? Because they are not working in the same environment, like, say, that's all that problems. Okay, so that's the problems we have right now. So in the end, we got to understand that the process that we are having so far does not scale. If you have large number of models that require a frequent update, and you have continuous new data that is coming in, continuous new models are getting implemented, we'll not be able to work with the current process which we saw. And the most of industries are using this current approach which we saw. That's why we are very clear that we need automation. Okay, so far you are convinced, like, what we saw so far, and what we are talking the picture. It's like, why we need the automation and why things will be breaking. Okay, hope that is clear to you guys, all of you. Anyone has any questions so far?
Yeah, Bhavesh, sure. So I have a doubt like in my mind. Can we put our the model like into production?
Sorry, what is the question? Can we
Yeah,
put our model in
yeah,
production?
model into production or like directly? No, right?
No, I mean, you have to, at the end, that's your goal, right? To put the model
Yeah,
in production. You cannot, like, do without testing, without any process. Like,
okay.
I
So
have developed this model.
we cannot, yeah,
Yeah.
we cannot land directly on the production only unless until we test it in the lower environment.
Yeah. So in the dev environment, say, like, that's what I am saying. In the dev environment, if you are using, say, example, let's pick up one example that will be clear. You have to predict the sales of March month. Okay. That's your goal right now. And you have a model which is trained on data from 2020 until like 2022 end. Okay, you have trained the model on this. Some data scientist has done this. He has took 1 month to train a very good model, right? So now you have the model ready, but you will have to test it on maybe 2023 data, you know, because we have the data up till 2022. So we'll have to test the data set, right? So 2023 will be tested. So this will be the testing data. And if the model is very good on the 2023 data, we can say, okay, now we have, you know, so let me, draw something out for you. Yeah, here this, my Figma board. So it will load in a minute. Okay. So let's say, what we are talking about is, some data scientist has a model training. Okay. So let's say, data science team has built this model. Okay. So model is built, model trained, but the model is trained on a data set worth 2020 to 2022. So you have been training this data using this, like, 3 years, 2020, 2021, 2022. Okay. Now we have a model output, right? So now we have a model output. Then we will put this model onto testing. Now there are two types of testing, One is evaluation of the model. Okay. The evaluation of the model is nothing but you do a internal testing. Now let's say you have a like you have some uh, data which is there already with you, 2023 data. So we are sitting on the timeline level. On the timeline, if you see, we are having the timeline as this is our timeline. Okay, so this is our timeline right now. So the timeline is like this is like 2020. So 2020 is there. Now you have all the things up till like this is 2022. Okay. Now similar thing you will have like 2023 timeline. So this is starting of 2023, and you have all the way you going here. Now you have 2024 start. This is now the data. So the model is trained using this 2 years, 3 years data, 3 years. Okay. Now you'll have to do some testing. So this is again, there is a different environments that we have. So usually this happens in dev, and so this also happens in dev. Okay. So now you have 2024 data, right? So you will also do, there's an internal testing. Okay. We say accuracy is 90%. Just say like I am keeping this. So if you see here, the accuracy is accuracy is 92%. Let's say when you train the model, so you do the model training and you test it on some sample set, right? So the accuracy when you trained the model was 92, and when we tested, okay, evaluation, that's the internal testing, on 1 year data, and then there will be some final testing, right? So which you will keep here, right? So if you see here, if I show you here, let's move it here. Okay. So this 2024 initial data, you will do the testing. So this can be in our stage environment. So here you are predicting, let's say for Jan and Feb, 2024. Okay. Now you have Jan and Feb output as well. Okay. Let's say you were testing, this was taking 6 months. So development effort was like this was our development effort. So let's say what is our development effort? This is our development effort. So this took almost it took like 2 months to develop this model, right? So another like uh, another like a few days it will take for you to test the model, like the 2 month it took test, train, and then this will happening internal testing on development. This can happen automated, manual, like within a day or two you already have the model. So now you will have to wait or maybe test it into stage, maybe for a few days, maybe for a few months, whatever, depending upon your timeline. And when you test it in stage, if you see like the model is working fine, then you will deploy the thing into prod. So this will be prod or maybe go live. Go live, that happens in March. So let, let's say that's our plan. And you say Jan Feb, we got accuracy is 89%. So which is close, right? 89 is close to 92. So that's what our process is. Like we need to see all of this. You getting that? So far it's clear. Like what we discussed, like how do you move from environment? I think someone asked that question, right? I think Naresh or
Yeah, 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 it's clear. Yeah, it's clear only.
yeah.
So,
So this is
a
how the
small
process
doubt.
yeah.
Yeah, accuracies keep on decreasing like stage by stage only. It's a little bit.
It's not that the case. I am talking about reality. It can be there, it
Okay,
cannot be there. If your model
okay,
is a so that's what I am saying you. like this is the case like when you are training on different data, and let's say in a newer case in the MLOps, right, you have continuous retraining, like you train this one model, but in every month you are training on newer data, so the accuracy will not decrease in that case, right? So this is like just in case I was showing you, like we were training, you are training the data on this one, it can be like it's very constant, like it was like 91%, then it's like this also is 91, then it's like this is going back to 90 or something, like that can happen. That's case to case basis. Okay.
Hi, Bhavesh. Rajesh here.
Yeah, Rajesh.
Okay, in the next coming 30 or 60 or 90 days, okay, what we are going to discuss, what frameworks or tools which we are using, okay, what confidence, okay, you are trying to give us, okay. Can you talk about that?
Yeah, yeah, sure. So wait, like I think we have to cover a few things here because we were having some questions, but yeah, that's in my plan. So let's quickly cover the things like let me open the thing. So Rajesh, I will answer that question in a moment. Let me yeah. So what is the MLOps? Let's define it. So MLOps is nothing but a standardized process for building, deploying, and operationalizing the ML systems. So what we mean by ML system, whatever we have seen so far, right? The data pipeline, training pipeline, the code pipeline is entirely integrated together, called as ML system, right? So that's what we need to focus on, rapid development and reliably deploy that. Okay. Then we have a MLOps framework. So MLOps framework is nothing but there are multiple things to it. Like you have a data, you have a ML, and you have a code like a web or app. Like there is a front end, right? If you're any of the things we'll be having. So data part, the data engineering, data warehouse will be coming down to the ML engineering. Okay, all the data will be as an input. So ML will take the input and process it, and if there is any feedback, we'll have this the gray line on this. Okay. And how about like if you have ML engineering but you are not deploying it somewhere or not using in the business, that cannot be the case, right? So your ML model can go to the business. So this is what a blue line group. So blue line all are the essential pieces, these are all the feedback loops. Gray line. Okay. And now again this web or app engineering will give the output back to the ML engineering. Like if say like some accuracy drops or maybe some metrics drop, so the web or app team can uh, drop us some some automated email or maybe whatever it's like you need to look into that. So these are some alerting mechanisms that you put in. Okay, this is all a rough concept which we are seeing, like how engineering teams are talking, or maybe like how different aspects of ML solutions are talking to each other. Okay. So this is what we are seeing. Now we will define the MLOps maturity level, and then in another 5 minutes we'll cover this MLOps maturity level, and after that we'll answer the questions. Okay, we'll reserve like another 10 minutes for question answers. Now we have, as we saw, what are the different maturity level. So we in GCP, like we are talking about only specific to GCP right now. So we have three maturity levels: MLOps level 0, MLOps level 1, MLOps level 2. Okay. The level 0, which we saw the diagram, right? It is a build and deploy manually. You know, there is only a like ops person and there is a data science person. Both talk to each other and do the things manually. In level 1, you have entirely the automation, of the training pipeline, of the deployment process, things like that. And in the third one, that's the level 2, we have complete automation, like right from the data to the code to the monitoring, everything is automated. Training, validation, deployment, everything happens automated. So that's the picture, high level. So let me go, this is our manual process which we saw. I'm not going to spend time on this. Let's say we are seeing level 1. Level 1 introduced this particular thing, right? The pipeline, we have now the training pipeline, automated pipeline that gives a model into the model registry, and then we do the serving. So that's there. And in the level 2 we have a CI/CD, like it's further automated, like the things from source code we build it, and then we do the cd deployment. Okay, so I think that's to the thing. But yeah, let me now cover. I think if there is any other question quickly you can ask. Otherwise, I can cover to what we'll cover in this course, and to answer some of the questions like what are the prerequisites and things like that. Okay.
Yeah, one more question. Rajesh, Rajesh again.
Yeah, Rajesh. Yeah.
Are we covering a good depth project or a basic example project in your sessions?
Yeah. Sure. I'll also cover this.
So tell me that, okay, whether it is an intermediate or a basic or the advanced also, and you are covering on bare metal or any cloud based also, can tell us, that will be a great help.
Cool. Perfect. Yeah. No worries. Let me open a thing now. Think This is our, yeah. So this is our syllabus that we have designed, and there are some additions to this syllabus based on what we have observed with the so far the candidates, and the training process. So first of all we'll cover the introduction to MLOps and key components of MLOps. Then we have what challenges. So the today's class was a part of this. Okay.
Yeah,
Then we have
Bhavesh,
here.
hello. Yeah, I'm sure. Yeah. So the MLOps is like creating pipelines and automation for machine learning models. Like, just like DevOps, how we create pipelines for web applications. So for ML application, as a MLOps engineer, we need to create pipeline CI/CD and a
Yeah.
production standard. Is that
Yeah.
I'm correct? Am I correct?
Yeah, you are correct, Surya.
We
So
need to create any models or algorithms. No need.
sorry.
Do we need to create algorithms or like do we need to write code for creating ML models? No, right?
No. You don't need to write that. That's not the. So yeah, let me pick up the questions later, because I think audience is more interested right now to learn what is the process, or maybe what we'll cover. So we'll take all the questions. So I would request everyone to wait for a few minutes, and then we can have the questions answered. So
Oh,
yeah, so this is what we will cover in the version control of machine learning system. So in version control of machine learning, we have three things, right? So the code systems, and then coding the model. All the models will be setting up in the version control. That is something known as a model registry. So we'll look at that, how the models are stored, what is the metadata. Then we'll create a collaborative development environment, like the GitHub, or maybe like there are some development processes in some cloud. You will have a notebook environment. So we'll look at all of that. And the other one is also the data version control. So we'll look at the data version control. So version control will be also covered in the three aspects. Okay. Then once we have there will be some training mechanism that you do, right? So there will be a custom job training, or maybe like on the go training, like on our local computer, or on our notebook environment. So the things that we will cover is all on cloud. So we'll not cover on bare metal things, but yes, you can replicate where we are using the cloud basic instance, which is a Jupyter Lab instance, or maybe like you can say 8 GB RAM, 16 GB RAM machine. So you can use your own machines and do all the code on that. Whatever we are going to learn in this particular class, you can do it everything on your. But for the say like we don't know what computers everybody is using. Somebody can use Mac OS, somebody can use Linux. That's why we are trying to keep it on a single cloud, on a single machine, or maybe like using the services, because we will be using some of the cloud services. And which cloud will be choosing, that is again I have a question that we need to ask to everyone, and then like they'll either submit a form, or maybe the institute will reach out to you for more information on what is your preference, and based on the candidate's preference in a batch, we'll choose a particular cloud. So we are open to all the clouds. That's not a problem. We are open to GCP, Azure, AWS, or any cloud, for that matter. So because we'll be learning the core concepts which are same, you know, if you do the development on this cloud or that cloud, it's the same. But we'll focus on the core concepts, and the things like how we do that. So that's not a problem, the cloud one. And as I mentioned, we'll be leveraging cloud for sure. So we'll be doing most of the hands-on that we'll do is on the cloud. Okay. So we'll talk about some automated testing for the model, how to do the unit test, how to do the integration, the CI/CD, like continuous integration, continuous deployment. We have covered the containerization or orchestration. If you know, like any production level code or model needs to be deployed into a Docker container for reproducibility, and if you have different ML environments, right, to productionize different, we'll see the like Kubernetes kubeflow pipelines, like there are some kubeflow pipelines that we look at. That's a training training pipeline, the ML orchestration thing. So that are all we see. We'll look at a model registry, as I mentioned, and the artifact management. So artifact management is more towards whatever code you write, how do you package it, how do you create a container, how do you leverage artifact registry. We also look at the data lineage, model lineage, all that things into very detail. And as I go further, we'll look into the model deployment, serving, different processes for serving, how we use the strategies, REST API, serverless, A/B testing, canary deployments. And once we have the model deployed, we'll look at the continuous monitoring and the feedback loop. As I mentioned, the models once in production, it's not like the job is done. We need to continuously set up monitoring pipeline. Similar to DevOps, we have MLOps also monitoring practices. We use things for monitoring, logging, and process like that. So last is we will have some security and compliances in MLOps. Like we'll look at the data security, data at rest, uh, encryption at on the fly, all that things, and some other things which will be there under this. Yeah. So this is a high level idea, but yeah, more things are added. The training pipeline which we have not written here, the inference pipeline which we have not written here. So things are added on that front. Okay. So whichever things are necessary for your job as a ML ops engineer, we'll cover all the things.
Yeah,
Thanks a
thank
lot.
you, Bhavesh. Yeah,
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 thank you.
thanks a lot.
thank you. Have a good time.
Yeah,
Thanks for taking your time out.
yeah, you too.